Recently, I did a setup and getting started video with the XTOOL D1 PRO. And if you guys haven't seen that video yet, click the link in the top right-hand corner of the screen because it got an overwhelmingly positive response. At the end of that video, I had also mentioned XTOOL sent me the RA2 PRO Rotary kit. Now this accessory here deserves its own video. There's a lot to cover. It's a very versatile tool. So that's the video that you're watching right now. The way that I'm gonna structure this video is that I'm gonna walk you guys through a bunch of different common use cases for this tool. And in most of those cases, I'm gonna engrave something for you guys and show you guys step by step how to go through that entire process. Now, if you guys see in this video any sort of accessory, tool, or anything that you're looking for more information about, chances are it's in the video description down below. I always bring this up in all of my videos. I try and provide you guys with the most amount of information possible, so be sure to check the video description below if you have any questions or you're looking for any extra information. And finally, if you guys appreciate the work that I do, you can help support me by checking out my website, embracemaking.com, where you'll find things like accessories and upgrades for laser cutters, 3D printers, and other maker tools. So let's get started. When unpacking the RA2 PRO, you're treated to a very similar unboxing experience as with the main D1 PRO machine. All of the components are well protected and the packaging is well thought out. In the small box here, you're going to be looking at the chuck accessories like the jaws, the chuck itself, and even the suction cup steady rest. In this larger section of foam, this is where you're going to find the main frame of the RA2 PRO, some wiring, tools, and the roller steady rest. You may also notice a few extra nice to have parts like the measuring tape, a small bubble level, as well as extra wiring adapters. The roller steady rest is adjustable with a knob on the top. The main frame is extremely solid. It's all built out of aluminum and metal components. There are very few plastic components, so it seems like it's of high quality. Even the chuck itself feels pretty stout, so that looks good. And the suction steady rest at the back also feels like a pretty nice unit. An additional timing belt is included for the chuck. And then for the chuck jaws, you get two different styles of chuck jaws. One of them is for gripping the outside of components, and the step jaws are for gripping the insides of things like cups. The jaws feel like they're coated in a nice, soft, non-slip material, so they shouldn't mar any of your workpieces. Throughout this video, I'll walk you guys through the purpose and uses for all of these additional accessories. Now before we jump into that, I want to address some of the upgrades that you guys will probably notice throughout this video. And these are things that I've done to my D1 machine, like this main board cover. It simply installs on top of the two standoff posts that sit right in front of the main PCB, and it just snaps right in place. You still have access to the ports and switches, it doesn't at all interfere with your workspace, and best of all, it keeps out the dust and dirt from your workshop or garage and provides a mechanical barrier so that tools don't accidentally make their way in there. If for some reason you do need to remove it, there is a finger pull tab on the left-hand side, and it will simply just pop off and pop right back on. At the top of the machine, I added this button cover to recess the button. This will prevent you from accidentally pressing it and inadvertently starting your laser prematurely when making last-second adjustments to your workpiece. I've done this a few times, and it can actually be pretty dangerous. It also protects your button from wood dust and other debris settling in on top of your machine from your woodworking shop or garage. If you're interested in these for your D1 PRO, check out my website, embracemaking.com. These two come in a kit, and that button cover comes in red or gray. So now let's take a look at the first and simplest use case for the RA2 PRO. And that would be using it in its out-of-the-box standard form with the two parallel rollers. And as you can see, if I roll one, the other one rolls, and that's because they are attached with a belt inside of the frame. The parallel rollers have three different positions for cylindrical objects of varying diameters. You can find the range for each of those positions in the instruction manual or right here on the screen. I'm going to be doing a very simple demonstration here for you guys with this powder-coated stainless steel water bottle, and it's got no existing logos on it, so basically we're going to be burning off the powder-coated paint and leaving behind the stainless steel for the pattern. The diameter of this water bottle falls into the range for position C, so I'm not going to have to move the roller, but I will show you guys how to do that later. Right now, I'm just going to point out to you guys that you need to use the risers that come with the RA2 kit in order to lift your D1 machine up a little higher so that it clears the rotary attachment. The leg extensions have male and female threads on the end, so they'll thread into one another, And then you can take these extensions and simply thread them into the existing legs on the machine. Remove the rubber foot off the bottom of the existing leg, and then, as I said, you just take that extension and thread it right in, and then you can put the rubber foot back on the bottom of the extension. Obviously, you're going to need to do this 3 more times. Once you're done, you can take your rotary attachment and place it in the middle of your frame. Right now you're looking at the machine from the front. You can see the XTOOL logo and the button on the right hand side. And the way that you want to orient your rotary attachment is to have the stepper motor on the right hand side of the machine. If you had flipped it around, what's going to happen here is that when you go to engrave something, you'll end up with the mirror image of it. With the RA2 now oriented properly, you can take the wire harness that came with the kit, and it has 2 white plugs on the end. One has 4 pins and one has 6 pins. The 6-pin plug will plug directly into the stepper motor, and you can see that there's a white connector on there. These connectors are keyed, so you can't plug it in backwards. The 4-pin connector is next, and that's going to connect to your main board. So you're going to have to take a look under the front of your machine at your main control board. When you first set up your D1 Pro, your Y-axis motor is connected to this plug here, and the rotary attachment is going to be replacing your Y-axis. Unplug the existing connector and just push it aside, and then plug in the 4-pin connector from your rotary attachment. Now we need to properly align the RA2 with the X-axis of our D1 Pro, and this is pretty simple to do if you have the right tool for the job. And for this, I use a rafter square or a speed square. And if you don't have one of these, I'll put a link in the video description down below where you can find one for cheap. Sit your square flat on the table and take the back edge and touch it to the front edge of your RA2. Move the gantry forward until it just touches the top of the square. So now the left side of the RA2 and the top of the gantry should be perfectly aligned. And you're going to move the square over to the right hand side, and without moving the gantry, you're going to reposition the right hand side of the RA2. So now again, both the rotary attachment is touching the square as well as the X gantry. Now you'll see me slide the square along the front edge of the RA2, and it's in perfect alignment with the X gantry. This is going to ensure that the image that we burn onto the water bottle comes out looking straight and doesn't look misaligned or crooked. The next step is to get the water bottle on top of the rotary attachment and flip down the focusing bar on your laser head. Line up the focus bar with the highest point of your water bottle, which would be the center axis of the bottle, and it should just graze the top in the same way it would work as if you were lasering a flat piece of material. When you're done, don't forget to flip the focus bar back up into the storage position. The RA2 is fully compatible with third-party software, but XTOOL does have its own native Creative Space software, so I'm going to demonstrate using this. I've imported an SVG vector file, and I'm going to drag it just anywhere in my workspace. If you guys remember from my first tutorial with Creative Space and the XTOOL D1 Pro, this is not using absolute coordinates, it's using relative coordinates, so the location of the image is not representative of where it's going to burn that image within the bounds of the machine. Otherwise, on the right hand side of the screen, you can see that I've selected laser cylindrical for the material. I've just selected a stainless steel mug. It's in roller mode, and I've clicked engrave, and that vector image has now been filled in. Now, if you guys want to enter your own power and speed settings on the right hand side that says user defined parameters, you can click that and enter your own. I've increased the speed to try and speed things up here a little bit, and I'm going to rotate my image here counterclockwise. And the reason for that is that my water bottle is sitting sideways in that direction. Then I'm going to hit proceed, and that's going to take me to this preview screen where you'll see that green dot in the top corner of the image, and that is the origin. You can change that with those buttons in the bottom left hand corner of the screen, but I'm going to hit the framing button. Framing allows you to visualize where your image is going to be burned onto your object. Move the gantry forward and backward until the laser crosshairs aligns with the center axis of the water bottle. This is going to ensure that the distance of the laser to the water bottle matches the distance that we set with the focusing bar. As the laser head and bottle moves around, the position of the crosshairs is going to represent the outer bounds of the image that you're about to burn. You can reposition your origin and reframe as many times as you need to until you're happy, and then you can hit the start button in the top right hand corner of the screen. When you're ready, press the button on the front of your machine and the process will begin. Now, I didn't go through the steps of what I did to generate this image, but I hope it's obvious to you guys that whatever image you're using should be scaled appropriately so it fits onto your workpiece. Vector files are the best to scale, and if you guys don't know what a vector file is because you're absolutely brand new to this, just Google vector versus raster image and you'll find a ton of information. And if you guys are looking for a nice piece of free software in order to generate or edit vector files, check out Inkscape. I'll put a link to that in the video description down below, as well as links to various tools that you'll see me using throughout this video. Also, if you're wondering at this point what that black nozzle is sitting at the side of my laser head, that's part of my fume extraction system that I designed, and this is something that you can also find on my website, embracemaking.com. I carry fume extraction nozzles for both the 10 and 20 watt versions of the D1 Pro. Direct links to those will be put in the video description. Once the job's done, we can take a look at the result, and at first the image is going to look black, and that's just the residue from the burnt paint that's still sitting on the water bottle. One of the first things that I notice here is that there are two distinct lines running through my image, and it appears that those two lines did not get properly engraved, and I'm wondering if it's time for me to clean my laser lens. After wiping the residue off the bottle with some soap and water, you can see the stainless steel exposed underneath, and the image otherwise looks very crisp with the exception of those two lines that got missed. I'll clean my lens before the next job and we'll try something different for the next example. For the next use case, we're going to look at longer and thinner objects, but since I just brought up the topic of cleaning, you should occasionally check your parallel rollers. They're made of a soft, grippy material that particles and things like to stick to, and this can sometimes get transferred over to your workpieces, which might interfere with the engraving process. Between jobs, I like to clean these off with compressed air, but rather than go through a bunch of disposable compressed air cans, I have one of these electric air guns. I had to try a few of them before finding one that rivals the power of a compressed air can, and this one has 3 different speeds with an LED inspection light built in. It's even been useful for cleaning up workpieces after engraving and cutting, and I'll put a link to that down in the video description below. Now that we have the rollers cleaned up, I can show you guys how to reposition them for smaller diameter workpieces. If you flip over the RA2, on the bottom side beneath each of the bearing blocks, you'll notice a single M3 screw. Removing this screw will detach the bearing block from the base, and in this case, because we're not completely removing the rollers and we're just repositioning it, I'm not going to pull the roller out. I can just push it towards the idler roller, which is on the opposite end of the RA2 base from the stepper motor, and then we can test fit our workpiece. In this case, I have this large wooden dowel, but position B on the RA2 is not quite small enough, and the dowel still falls in between the two rollers, so I can push it one step farther to position A, and then replace that one M3 screw. Now it fits on the rollers, but we're presented with another problem. And this piece is so long that the center of gravity is over the edge of the rollers, and you can see that it's tipping over. And this is where the roller steady rest will come into play. Using the screw knob on the top of the roller steady rest, I've lowered the roller to the bottom position. I've placed it now under the free end of the wooden dowel, and then using the adjustment knob again, I've raised those rollers up just to the point where it starts to come into contact with the wooden dowel. With something like this uniform profile wooden dowel, you don't want your roller steady rest to be pushing up on it. You want the center axis of the dowel to be parallel with the ground. Another common use case for the roller steady rest are things like wine glasses or flutes that have a stem on the end. This particular one that I have here has a heart-shaped pattern on it, and that's raised from the glass portion. And so I don't want that touching the rollers because of course that's going to wobble the glass around as it turns. So I'm going to support the main body of this glass on the area without the heart-shaped raised pattern, and I'm going to put the stem on the roller steady rest. Anytime you're doing something like this, whether it's the glass or the wooden dowel, you want to manually turn the rollers by hand and make sure that your object isn't walking back and forth or wobbling in any strange way. It's very common to have to reposition the roller steady rest to get its center aligned with the center axis of your workpiece. Next, we have the popular mug with a handle, and it quickly becomes apparent that when you have a handle, the regular rollers are not going to work for you. This is where the chuck attachment comes into play, and I'm going to show you guys how to install that now. Before installing the chuck attachment though, we do have to remove these two rollers. The drive roller on the end has 2 set screws on that collar. You can simply loosen those off and then remove the single M3 screw on the bottom of the RA2 for each of the bearing blocks. Once we get those off, the idler roller will just pull right out, and the drive roller, now that you've loosened off the 2 set screws, that can also be removed by simply pulling it out. The chuck attachment comes with some additional hardware and accessories, all of which I've been able to fit and store in one of my 3D printed snap latch cases. This is also something that you can find on my website if you're interested, and so I'm going to hop into that hardware bag and I'm going to grab the M4x20 button head cap screws. Position the chuck on the top of the RA2 body, and you'll find that there's a small recess in the very top where you'll see that the chuck fits in nicely. And position the chuck with the jaws on the same side of the RA2 body as the stepper motor. Use the M4x20 button head cap screws to secure the chuck down onto the body of the RA2. Now I'm going to hop back into my accessory case and I'm going to grab the soft jaws. These ones are the non-stepped soft jaws, so these are intended to grip the external surface of something like a cup or mug, and I'm going to be trying these ones out first. Alternatively, the stepped version is what's meant to grab the insides of cups and mugs, but we're going to try the external version first. In the soft jaws, you'll find 2 holes intended for M4 button head cap screws, and those M4 screws are also included in your hardware kit. I'm going to be installing my soft jaws into a position where I can get 2 of the screws into the chuck, but as you move those jaws out, because they are adjustable, you may find that the outermost positions, you can only use 1 screw, and that's more than good enough for what we're doing here. Off camera, I've tackled the other 2 jaws, and now we can address the missing pulley at the back. In order to turn the chuck accessory, we need to install the included pulley behind the stepper motor, and you'll find this small black pulley in your accessory kit with 2 set screws. If you look very closely at the drive shaft behind the stepper motor, you will notice that it has a small flat spot on that shaft. So it's sort of a D-shaped shaft, and at the very bottom of the RA2 body, there's an access hole. Before installing the pulley, you want to carefully align that flat spot with the access hole at the bottom, and you can use some needle nose pliers to do that. Be gentle with the needle nose pliers and try not to mark up the shaft. Then you can take the included belt and the tooth pulley. You can wrap the belt around the pulley on the chuck, and with the belt still wrapped around the smaller pulley, you can slide that over top of the drive shaft. When positioning that pulley on the shaft, you want to line it up such that one of the set screws is in line with the flat spot on the shaft so that it's accessible from that access hole on the bottom. Then you can tighten that set screw, spin everything around manually by hand, tighten the second set screw, and now you're ready to install the mug into the chuck. If you've never used something like a drill chuck or a lathe chuck, usually they come with one of these keys, and the end of the key fits in one of those holes, and the teeth on the key engage with the teeth on the chuck, and you're going to turn that thing clockwise in order to tighten up the chuck jaws around your workpiece. And now, despite going through all of that effort, we still have the problem of the mug now hitting the metal base. Luckily, we can reposition this base to the other side, and all we need to do is remove these 2 long M3 screws. The base is then fully detached from the RA2 body, and you'll notice that on both sides of the base there are tapped holes. So you can flip this base around any which way that you want. It doesn't really matter which way you go and install this thing. And now, even with the base repositioned, I've still got the problem now with the mug handle hitting the table, and by no means is this an extra large sized mug. I've seen people stack things under the metal base to raise it up, but I do have a better solution that I've designed here, which adds even more functionality to your RA2. And this is a riser and tilt mechanism that I've designed that fits between the metal base and the RA2 body. This is far easier to use and far more accurate than just sticking random things underneath the base to raise it up, or wedging other items under there to angle the bottom metal base plate. Later in the video, I'll show you guys why you would want to angle one of your workpieces, but for now, I'll show you guys how to install this riser and tilt mechanism onto the base plate, and we'll do the most basic example first. With the riser and tilt mechanism kit that you can get from my website, you'll find a bag of hardware, and in that hardware, you'll find these T-slot inserts where you'll fit inside M3 nuts. The thin M3 nuts will sit just inside of these inserts, and then the easiest way to get these inside of the T-slots of your metal base is to go on and put them in the end where the bearing blocks would normally sit. It'll just sit flat in there, and then you can slide it forwards, and you're going to do all 4 of these. There are other people who have designed tilt mechanisms for the RA2, but I've yet to see somebody take this approach. The tilt mechanism that I designed is symmetrical with the exception of these tabs up at the top. One side has M3 nuts pressed in, and the other side has counterbore holes for the heads of the M3 button head cap screws. These are the same long button head cap screws that were previously holding the metal base to the body of the RA2. You can install this thing in either direction, but I would recommend pointing the counterbore holes towards the back side of the RA2, and that's just going to make it easier to thread in those longer M3 button head cap screws. But first we need to attach the mechanism to the base, and to do that we're going to take the included M3x10 socket head cap screws and the M3 washers, and we're going to put those through the slotted holes in the main body and thread those into the M3 T-nuts that we've created using the slots. I haven't fully tightened the M3 screws just yet. I'm temporarily putting the RA2 body on top, and I'm going to slide it forwards so that the handle clears the plate and the table, but not so far forward that the whole thing tips. Once I've found a good position for this job, I'm going to take my speed square and I'm going to line up the edge of the speed square with the edge of the tilt mechanism assembly, and that's just going to make sure that it's perfectly square with this metal base plate. This is going to be important because later on we're going to be aligning the base plate with the gantry on the XTOOL D1. Now we can take the RA2, place it on top of the tilt mechanism. Those holes in those tabs on the tilt mechanism will line up with the holes in the bottom of the RA2 where the base plate used to attach to. And now we can reuse those long M3 button head cap screws and fasten the assembly to the tilt mechanism base. Just remember that you're tightening these things into plastic parts, so don't go too crazy with how tight you make them. On both sides you'll find 2 M5 socket head cap screws. The top one you will not have to adjust, and only the bottom one you'll ever have to loosen or tighten. And when you make them loose, this allows you to tilt the whole assembly back and forth about 40 degrees in either direction if you need to. In this case, since our mug is just straight with no taper, we can set this thing up so that the mug is again parallel with the table. Placing the bubble level on the surface of the mug helps us to verify that it is level, and then you can just tighten down those 2 M5 socket head cap screws on the bottom of the mechanism. This will lock the position in place, and again, do not over tighten these. So now we could proceed to etching if we wanted to, but this wouldn't be a thorough guide if I didn't walk you through a few more things, and that would be the expanding step jaws. You can see that the jaws that I'm using right now to grip the outside of the mug take up a certain amount of real estate on a pretty short cup like this. When traveling back and forth over top of this mug, the guard on the laser module is likely to hit those jaws. This is really going to put a limit on the size of the image that we can burn onto a mug like this, so I'm going to show you guys how to switch over to the step jaws. You'll need to remove your workpiece, and then you'll need to remove each of the 2 M4 screws holding each of the jaws in place. The step jaws will install in place using the same M4x10 button cap screws, and there are several positions that they will fit on the chuck accessory. And so in the smallest setting, you'll be able to fit both screws through and secure the step jaws into place. And as you move them outwards to accommodate larger mugs and cups, you'll notice that you may only be able to get 1 screw into place to fix those jaws to the chuck. In my case, I've got mine set to the outermost position, so I've only got 1 screw in place, and I'm going to be using the second step on these jaws to secure my mug within the chuck. And it doesn't matter which set of jaws you're using, don't over tighten your chuck. You do not need to put a lot of clamping force on your workpiece. The workpieces are just being lasered, they're not being machined, so do not go crazy with how tight you make these things. You could potentially crack the plastic jaws. Now we can transfer our entire setup into the frame of the D1 Pro, double check that our mug has not moved and it's still level with the top surface of the table. We can grab our square, and just as I showed you earlier in the video, line up the RA2 with the X gantry so that the image comes out properly aligned with the mug. Flip down the focusing bar, and just as we did with the blue water bottle earlier, we're going to be focusing the laser to the highest point on the mug. Since this mug is on the upper end of what this chuck can natively handle, with the addition of the riser kit, the laser module no longer clears the mug in its highest most position. But again, I have a solution for that as well. With the tilt and riser kit that I offer, you get leg extensions for your leg extensions. And so what you'll see that I've done here is removed the bottommost extension from the XTOOL D1. I've also removed the rubber foot, and now the 3D printed extension press fits into the bottom of the leg. And when you want to remove it, I would recommend unthreading it versus just pulling it straight out. The bottom of the new extension also has a hole in it, so you can replace the rubber foot, and it press fits into there as well. Also, when you press fit the new black leg into place, it's totally normal to have that 2mm gap. It's designed to be like that, so don't try and keep pressing it or forcing it in any further. With all 4 legs installed, we now have the appropriate amount of clearance from the laser head to the workpiece, and now I can flip down the focusing bar and we can focus the laser to the highest point on the mug. Also keep in mind here that when installing those feet, I did disturb the position of the machine relative to the RA2, so I did have to go back and realign the RA2 with the X gantry using my square. When you're done, don't forget to flip the focusing bar back up. Now I have the machine on, you can see the crosshairs and we're ready to laser, right? Wrong. Even though I've moved over to the step jaws that go on the inside of the cup, if I want to laser an image on this mug a little bit higher on the mug, you can see the laser guard is still going to hit the jaws. Now the solution here is to remove this guard, and it's not difficult to do. I will show you how to do it, but you will be doing this at your own risk. Running the machine without this guard poses an obvious risk, and I would highly recommend that you practice good safety by wearing your laser goggles. First, turn your D1 Pro off and unplug it. Completely remove any power source from the machine. Then release the laser head module and take a look at the back. You'll find 2 holes in the back near the bottom of the module, and you'll see 2 set screws. Loosen off these set screws and this will release the laser guard. If you still have the air assist fitting in place, the laser guard won't fall off just yet. Use a wrench to release the air assist fitting, and then you should be able to slide the laser guard out of place. Then you can put the air assist fitting back and install everything in reverse order. Now you can see that I can get the laser head much closer to the end of the cup without making contact with the chuck jaws, and this gives me much more workable space on my workpiece. One other thing to take note of here is the position of the handle. I have it facing down, completely opposite of the laser. And the reason for that is that I want my image centered on the opposite side of the handle. Now I'm going to head into XTOOL Creative Space, import my SVG image, switch over to the engrave mode and drag that image somewhere in my workspace. I'm going to rotate this 90 degrees clockwise this time. And this is different from the last time where I went counterclockwise, and that is because the mug has been flipped over 180 degrees and it's facing the other direction. I've also clicked on chuck mode, and in chuck mode you have to enter in either the circumference or diameter of your cylindrical object. This time I do have a black stainless steel mug, so I'm going to select that preset and I'm not going to change any of the parameters. Now I can click down on the process button, but it looks like when reselecting the material preset, it erases the chuck diameter. So I'm just going to enter that back in as 91mm. And now in the preview window, I'm going to select the circle in the top center of my image, and this is going to be my new origin. And the reason I picked the center instead of one of the corners is because this is going to make it very easy for me to align that image directly opposite from the handle. Therefore, when I go to perform the framing, the crosshairs is going to represent the starting position, which is the origin, which is the top center of my image. And as soon as I press the button to begin the framing process, the crosshairs is going to outline the image, and it's going to move left to right on the mug. And when the framing is complete, the mug, if I've done this correctly, should end up back in the start position. And that means the handle is going to be facing opposite of the laser again, in which it does, as you see here. I'm going to move the laser head to the left just a touch, and this is going to move my image down on the mug. And just remember that when you guys are framing your image onto your object, it is the laser crosshairs that you're going to pay attention to and not the center of your laser module. When you go to process your job, the machine will take care of that offset between the crosshairs and the laser, and of course your laser will move to the correct position and laser your image where you intend for it to be. While this job is running, I just want to point out that I could have potentially set this up with the step jaws in the smallest position, and then I would have gripped the cup with the very outside of the step jaws. This would have allowed me to leave the guard on, but I didn't do it this way because I found it very difficult to align the cup properly with the chuck. By moving to the next notch down, I could take the lip of the cup and press it right up against the shoulder of that last step, and this is going to make sure that the cup is properly aligned with the jaws and the center axis of the chuck assembly. And so if you decide to do it the same way, I cannot stress enough to exercise caution, as this machine is already fairly inherently dangerous, as it does not have any enclosure built around it. The laser can be reflected into your eyes, and this will surely cause eye damage. So again, please be careful if you do it this way. In the end, the result was well worth all of the effort, and the logo turned out crisp and sharp, as well as the text. I've read online that some people have had some issues cleaning up their mugs post engraving, specifically the stainless steel type with the powder coated surface, but I've had no such issues. Just a wet paper towel is enough to remove the remaining residue, and I'm left with a really nice, clean looking mug. I'll put some links down in the video description below where you can find multi-packs of these blank mugs that you guys can use for your own project or your own business. If you plan on starting a business and want to legally sell items like this one with trademarked logos on them, you're going to need a license from the trademark holder. This example here is for personal use and is not for sale. The next example that I have here is something like a tapered tumbler or one of these short stemless wine tumblers. You can see that if you try and put something with a taper on the regular rollers, when you go to roll the rollers, the tapered object tends to wobble or walk along the rollers. This is obviously going to distort our image, and even with the roller steady rest, I've found that it's really not all that stable, so I'd rather use the chuck system. Using the tilt mechanism that I designed along with the chuck, it's going to allow you to take this tapered surface and properly align it with your X gantry. I'm going to be using the step jaws here to grab the inside of the cup, and remember that when you're using the step jaws, you're going to have to turn the key for the chuck in the opposite direction to expand the jaws and grab the inside of the cup. Right now the axis of rotation is still parallel with the table, but with the taper on the cup, you can see with the bubble level that the surface that I want to engrave on is not parallel with the table. So we're going to fix that. Looking at the sides of the tilt mechanism, we're going to loosen off the M5 screw on both sides, and this is going to allow the entire thing to tilt in either direction. Being able to tilt in either direction opens up a lot of possibilities for you to engrave a wider variety of objects. Now for this cup here, I'm going to tilt it down a little bit, and that's going to allow me to get that surface I want to engrave on parallel with the X gantry. And once I find the correct position, I can just hold it with one hand and gently tighten those M5 screws on the bottom with my other hand. I've mentioned it before, but just another friendly reminder, you don't have to over tighten those screws, we're just holding a cup. Now we can get the entire assembly back inside of the D1 workspace, and I've squared up the RA2 with the method that I showed you earlier using the speed square. And now we can double check that the surface of the tumbler that we want to engrave is in fact parallel with our X gantry. And to do that, you're going to flip down the focusing bar, and over top of the highest point on that surface, you're going to drag that bar across, and it should be equal distance from the top surface of the cup or workpiece through the entire travel. Next, I'm going to grab a measurement of the circumference in the middle of the taper, and that should give me a pretty good average for a value that I can enter into the Creative Space software in a minute. Now I've imported my appropriately scaled logo into Creative Space. I've selected laser cylindrical. I've selected for material the black mug. I've also selected chuck mode, entered the appropriate diameter into the diameter setting, and I've rotated my logo 90 degrees counterclockwise. And now I can hit the process button. Even though I don't have a handle on this cup, I still like to have my origin somewhere in the middle rather than in one of the corners, and so I've set my origin to the top middle of the image. Next, I'm going to align my laser crosshairs with the center of rotation of my object, and sometimes when you have a larger object or an object with a taper, it's a little harder to estimate where the center is, and so I like to use the center of the chuck. Then I can move the crosshairs over to where I want the top of my image to be located, and we can perform the framing. This time during the framing process, you'll notice that I run into another issue. And despite having already removed the laser guard, the laser module itself now comes into contact with the chuck jaws. At first I was concerned about this situation, but then I reminded myself that the framing is done with the laser crosshairs. So because the laser module just touched the jaws and it wasn't really a huge collision, when the job goes to actually run, the laser head will be offset to the left and it'll be in the position of the crosshairs. So it actually won't hit the jaws when the job's running. And so I was comfortable making that judgment call, and because of that small amount of contact, I just had to double check with the speed square that the entire assembly was still in alignment with the X gantry. Thankfully, this job ran smoothly and there were no other surprises during the process. The tilt mechanism performed wonderfully, and if I had a batch of these cups to do, it would make the setup process very repeatable and quick. One other useful accessory here that has been easy to overlook is the silicone mat that I have on top of my work surface. It protects your table from unwanted laser marks, but as an added benefit, because the silicone has a non-slip surface, when setting up new workpieces, it prevents your RA2 from moving around. This will prevent you from accidentally knocking things out of alignment when setting up a new workpiece, and this goes back to making things very repeatable, and if you're running a business, very efficient. I'll put a link to these silicone mats in the video description down below. Taking a look at the end result of this engraving job, I was really impressed with how the finer details of the Porsche logo turned out. It might be a little difficult to see, but within the lettering in the crest, there is a bit of a drop shadow effect, and the lines are very, very fine. I thought that maybe that detail would be lost in the engraving process, but after cleaning this thing up, if you look very closely, it's still there. And these are extremely fine lines, probably the width of a human hair, and I'm surprised they turned out so well. So I must have got the settings right. One of the final things we're going to look at here is using what I like to call the fingers. Honestly, I don't know the technical name for them, but you can see here that I've removed the chuck jaws, and these are the little fingers that I'm talking about. One end has a thread on it, a male thread, and the other end has a ball. Now, the male thread threads into the same female threads that you would use to attach the chuck jaws. You can position them in any of the holes to grip a variety of different sized objects. In this particular case, I'm going to start off with a Christmas ball ornament, and this is roughly the same size as a tennis ball, and so I've used the outermost holes in the chuck. Now, this thing here, I'm not actually going to engrave because I don't know what it's made of. And for laser safety, you shouldn't be engraving things that you don't know what the material is. Certain materials like PVC can release nasty gases when vaporized. Now, these fingers alone won't grab something like a spherical object. You need to use the suction cup steady rest. This suction cup steady rest has a built-in spring, and it's going to apply some amount of pressure to keep your spherical object pressed up against those fingers. And the steady rest slips into the metallic base using the T-slots. Now when I go to turn the chuck, you can see the entire ball moves as well. And so this will rotate around and obviously allow you to engrave. If you find that the suction cup steady rest is slipping, there is a brake on one side, so you can turn that counterclockwise and that will lock it in place. Now when you go to engrave a spherical object, you're likely going to focus on the highest point of the sphere, which would be right in the center, and likely that's where you're going to be engraving. If you have a large enough image that it's going to wrap around the object, the laser might lose focus at the extreme ends, and your image might look a little distorted or even blurry. Repositioning the fingers to the inner holes allows you to grip the inner diameters of smaller objects like rings. I did find that accurately positioning small objects like rings on these fingers is not the easiest thing to do. You have to fiddle around quite a bit, and at the end of the day, what you're engraving on is very small, so you don't have a large margin for error. That is, of course, not to say that it can't be done. You just have to take great care in your setup. And last but not least, I've also seen people engraving the inside of rings. And to do this, you would grip the outside of the ring using those fingers, and you're going to need to tilt the entire RA2 assembly on a pretty severe angle in order to get the laser to engrave the inside of the ring. Finding the sweet spot where the ring sits nice and snug inside of those fingers can be a little bit frustrating.
I did find the best way to do this was to just start unthreading each of the fingers so that the flat spots on the fingers sit against the surface of the ring. This should prevent the ring from wobbling around, and it should rotate nice and smooth. Tilting the ring up on a severe angle is pretty easy to do with my tilt mechanism kit, and just as we did before, you're going to loosen off the bottom 2 M5 screws, and that's going to loosen the whole assembly up so that you can rotate the RA2 body. Now, it can rotate up to 40 degrees, and that should be enough to allow the laser to access the inside surface of the ring. Just don't forget to tighten up those M5 screws on your tilt mechanism before starting your job. XTOOL recently released an IR laser module, and that's going to be way more efficient at marking things like metal. I'm going to reach out to XTOOL and I'm going to see if they want to send me one so I can make a future video about that for you guys.
And so that's it for the RA2 rotary attachment video. Thank you guys so much for sticking around right to the end. If you want to see more content like this, hit the subscribe button down below. I've got more great videos coming up for you guys. And if you guys want to go the extra mile and support me and my work, check out my website, embracemaking.com. That's where you're going to find those accessories like the PCB and button cover, as well as the riser and tilt mechanism kit, and the fume extractor that I showed in the original D1 Pro video. So thanks again for watching. I hope to see you guys in another video.